So in the previous video, we took a look at how we're creating these raindrops and making them fall and regenerating more raindrops each frame. Now we want to take a look at how we set up the red and green boxes to represent people moving slowly across the parking lot and more quickly across the parking lot. So we're going to call those two objects slow and fast. And we're making a call to a new class of object I made for this called Collider. We have to give it a few arguments. Let's take a look at it up here where we define the class Collider. So it requires a few things. It requires, first of all, the position, so the starting location. It requires the size of the colliders. It requires their initial velocity and a color that we want to assign to them. So that's what we've got down here is the position is just to the left of the minimum x, or starting just to the left of the rain field. We give a size, so we're just giving length, width, and height, and then we give an initial, or we give the collider's velocities. It is the initial velocity; it's also the constant velocity. So for the scenario we ran for the rain problem video, one of them is traveling at a speed of 0.5, one of them traveling at a speed of 1. So we're dealing with one of them is moving twice as fast as the other one. And then, of course, we give them their colors. Red for slower, green for faster, just like we associate with traffic lights. So if I scroll back up to the Collider class, basically we're setting all the information we need for these colliders, both to move them and to check for collisions with the raindrops. So we need to assign their position, their color, their size, etc. And then we need to start to assign their edges. So these are the values that we're going to use when we're checking for a collision with a raindrop, because basically we're looking for whether a raindrop has made it into the space of one of the colliders. So we have to give it a top side, a bottom side, a right side, a left side, a front side, and a back side. And these are all just their positions adjusted by their size dimensions. So when you input a position of a box like this in VPython, it takes that as the position of the center of the object. That's a pretty standard convention for 3D objects. And so basically we're adding on half the size in the Y direction, the X direction, the Z direction, or subtract them off to move over to the right edge, to the left edge, the top edge, the bottom edge, the front edge, the back edge. Then we create the actual box shape itself so that we have a visual. We give the thing its velocity. And then we have to set its number of raindrops collected. So we're initializing that to 0 because they start off dry in the building. And then we assign to each of them a couple of graphs. Now we'll take a look at how the graphs are generated in the next video. So we're going to skip over that for right now. And then the last step is to add each collider to the list of colliders. So this collider list is just a way to keep track of all of the people we have moving across the parking lot. In the current simulation, we've got two of them, one moving slow and one moving fast. But if I wanted to add a third one, I could add one that's moving at, say, medium speed. And I'm just going to copy and paste this. I could have this person start out, let's say, halfway between the two, and then give them a speed in between the two, so give them a speed of 0.75. And then what that will do, oops, I keep hitting Control S to save instinctively, even though this thing automatically saves. Anyway, what this would do is it would create another collider, and it would just add it to that list, because when we go to check for collisions, we're going to loop over all of the colliders in this list. Oh, and I need to give this guy a different color. Let's make this one yellow. There we go. Yeah, traffic light, red, yellow, green. There we go. So what we do to move these things is we use this, just like we have move raindrops, we have a move colliders argument here, or function. So let's take a look at that. That's pretty straightforward. We're looping over all the colliders in collider list, so I don't have to do anything extra to add the movement of this medium speed collider, because this one is, let me align that, there we go, because this one is automatically added to the collider list. It's also going to have its motion taken care of in here, because it's going to go over every object in collider_list. And what we're doing here is we're just checking for whether we've reached the right edge. Have colliders reached right edge. Actually, that shouldn't be plural. That should be collider. It's looking at that particular collider because this way we have the colliders stop when they get to the car. And so what we do is we update the collider's position. So again, just Euler-Crömer method. I don't have them accelerating. That might be an interesting thing to look at, but people don't generally accelerate that much when they're moving. We get up to speed pretty quickly, so we're moving at constant velocity here. And then once I've updated the position, I also have to update all of those edges again. So when we set the edges here, that's their initial value. So this thing, this init routine only gets called when the collider is created. This does not get updated. So I need to update their edges here. I suppose I could make a separate subroutine for updating their edges, but this is the only time I have to do that, so it works just as well to have it here. Then what we have to do is we have to check for collisions with these things as they're moving around. The way we're doing that is in the raindrops routine. So we didn't see anything about collisions here in the move_colliders. We're going to check for that in the move raindrops. So I've made an addition there from the code you saw in the last video. So if I look at move raindrops, what we do is we've got what we had before. We've got updating their velocity, so they're accelerating downward. Then we update their position. And then we need to check for a collision. And we're doing that using another function called collision. So having all these nested functions helps you be able to make simple changes in nice little pocketed areas of the code without having to read a whole bunch at once. So here I just know if I get a collision for this raindrop, then I do the same thing I would do when it collides with the ground, is I would make the raindrop invisible and then I would delete it from the list, and then it would continue to loop around until I've gone over all of the raindrops in the list. So let's take a look at this collision routine. So this is a thing, remember, attached to the raindrop. So it passes that raindrop as an argument, and basically this is set to return true if there was a collision with a collider and return false otherwise. So we have our collider list here so that we know what objects to look for as colliders. And again, we're just looping over every object in the collider list. And here's where we check for whether the raindrop has entered the collider space. We want to know if it's fallen within its left to right bounds. So is it within the left and right edge of the collider? Here we check, is it within the top to bottom edge of the collider? And here we check for whether it's in the front to back edge of the collider. Colledge, that should be a shorthand for collider edge. Colledge, I like it. And so here we have an and between each one of these because they all have to be true, right? It's not enough for the raindrop to be between the left and right edges, because if it's between the left and right edges but is up above the collider, then that doesn't count as a collision. And then we have to do a couple things. We add 1 to the number of drops that collider has collected. I don't have a way to mash together collider and collected because that would just be collected. Collected? Maybe. Let's see. So this was this value up here. We had this self.drops that we attached to a collider. So again, this is the number of raindrops collected. So we just increase that number by 1 here. And then we return true. So we say, yes, there was a collision. And otherwise, we return false. So basically, as soon as we know that there was a collider, we can return from here. That there was a collision. We don't need to keep updating this thing in order to... and we don't need to keep looping over the colliders, because once there's a collider with 1, we know that there was a collision. A raindrop can't collide with 2 colliders. Although now that I think about that, I might need to thin these folks out in the Z direction because I think they're going to overlap a little bit. So if we're going to have 3 there, let's go with 0.5, 0.5, 0.5. I think I need to do that. I could be wrong, but there I go again. I think I need to do that. Let's see. And yeah, that's pretty much it. So then we have our stopping condition on the move collider. So that tells the colliders when to stop. Let's run this thing with our new yellow medium collider. I haven't tried this yet, as evidenced by the fact that I didn't know what size to give them. All right, here we go. We've got our red, yellow, and green. Oh, I did give them... Okay, I didn't have to give them that much space in between each other. Oh well. The important thing is that we've got it where, and there's our raindrops falling. I need to zoom in to be able to see that. The important thing is we now have a yellow one here, and so everything that happens to green and red also happens to yellow, so it's being moved. I never told it explicitly to move the yellow one. I just said move all the colliders in the list. So that's one of the beautiful things about having those list loops like that. And here we've got our graphs. Again, we'll take a look at this in the next video, but we've got a graph for the yellow one as well, because again, anything you do for red and green is going to happen for yellow as well. Let's see. Yeah. So you get the same type of results you expect to see. There's a much larger gap between the red and the yellow than there is between the green and the yellow, even though their speeds differ by the same amount. So that's interesting. I wonder if that would be something interesting to explore. I haven't played around too much with the speeds. I'll leave that up to the viewers to play around with. So that's how the collision detection works. In the next video, we're going to take a look at how we generate these graphs and get an idea of why it's important to look at both the raindrops versus time as well as the raindrops versus distance. So thank you so much for watching. I will see you next time. Bye-bye.